So we are continuing with our 2D notes talking about transformations. So hopefully you have your 2D note packet in front of you. We already have done the front page of this. The top part was talking about the translations, which are the shifts. And then we also talked about reflections over the X and Y axis. And so today, our last type of operation are stretches and compressions. Okay, so this is on the back side. So find this part. So stretches and compressions are like dilations that you might have seen in geometry, but we're only affecting one of the values, either the X value or the Y value, not both necessarily at the same time. So when we're trying to figure out if we have a stretch or compression, we're going to have to look at where the number is. So if you look at all of these, we're multiplying by some number C. So we're multiplying by a number, which is going to either stretch or compress the graph. We have to decide whether it's on the inside or outside, so whether it's affecting the X or the Y. And then whether it's a stretch or compression will depend on what the number actually is. So let's fill this part in first. So what type of stretch or compression each of these is. So if we look at the first one, C f of X, so notice this is multiplied by the C. C is on the outside. So I know this is affecting the outputs, which means it's stretching along the y-axis. It's affecting the outputs or the y's. If something is stretching along the y-axis, it's either getting taller if it's a stretch or shorter if it's a compression. So, but I know it's along the y-axis, so I know it is vertical. Then if C is greater than 1, so C is the number we're multiplying by. So if C is greater than 1, that's like a number like 2, 3, 4. That's going to be a vertical stretch. The operation we're going to do, when we see the number on the outside, this is multiplied, C multiplied by f of X. When the numbers on the outside are affecting the Y, we just do the operation we see. So the operation we would do here is we would multiply the Y value by C. Multiply Y value by C. And since C is a number greater than 1, it's going to make the Y values bigger or be a vertical stretch. The second one is still C on the outside. So C f of X. So it's still vertical. But the difference on this one is the C value. This expression says 0 is less than C is less than 1. This means C is between 0 and 1. So it's like a fraction or a decimal. So this one is going to be a vertical compression. Vertical compression. And it's the same operation. The C is on the outside. It's affecting the outputs or Y values. So we just do the operation we see. That means we're going to multiply the Y value by C. This time though, C is a fraction or decimal, so it makes the Y values smaller. So that's why it's a vertical compression. All right, so let's make sure we have both of those written down. So C f of X, if C is greater than 1, is a vertical stretch, and we multiply the Y value by C. C f of X, if C is between 0 and 1, is a vertical compression, and we multiply the Y value by C. So same operation on both for the Y value. Now the second two. We have f of cx. This is still multiplied by c, so because it's c times x, but this time the c is on the inside on both of those. If the c is on the inside, it's affecting the inputs or x values. So we know it is stretching or compressing along compressing along the x-axis. So we know that this is going to be horizontal. Now, this one is a little tricky on the stretch or compression. Remember, when something is with the C, we do the opposite operation. So here, since this is the operation I see is C times X, the operation I actually have to do is divide the X values by C. And so if C is 1, that's going to make the X values smaller. So this one is actually going to be a horizontal compression if C is greater than 1. And the operation we're going to do, remember when something's with the X, we do the opposite operation. So I'm going to divide the X values by C. Divide X values by C. Horizontal compression and divide X values by C. So that means the second one, or the last one here, f of cx is still multiplied. This time the difference is the c is between 0 and 1. It's still horizontal because it's still affecting the x values. This one, though, is going to be a horizontal stretch. Horizontal stretch. And the operation, it's still the c times x is still with the x. So we do the opposite operation. We're going to divide x values by c. But if we're dividing by a fraction or a decimal, that actually is going to make the x values bigger. So that's why it's going to be a horizontal stretch. Okay, so make sure you have all of those written down, or take a quick screenshot so you can get those written down. Now let's do some examples here. As you can see, we have two of the same graph drawn over here on the left. So we're going to do, there's 4 transformations we're going to do. A and B, we're going to do on this graph. The reason there are 2 graphs is just because I didn't want to have to try to fit all 4 transformations on one graph. It would just be too much to see what's going on. So we're going to draw A and B on this graph, and then we'll draw C and D on the other. Okay, like we've been doing, the first thing we have to do is find the points on the original. This one here in black is our original. And as you'll notice, the points are actually already listed on there. I'm just going to write them down so I can use them. Okay, so we have the points -2, 4. Here, this one is 0, 3, 1, 0, and 3, -1. -2, 4, 0, 3, 1, 0, and 3, -1 are original points. All right, so we're going to graph both A and B on this same coordinate plane. I am going to do them in different colors so we can see them. If you look at both A and B, they're both multiplied by a 2. So this one we have 2 times f of x. This one we have f of 2x. Either way, they're both multiplied by a 2, but they have different effects on the graph. So let's look at A first. We want to say what kind of transformation it is and what operation we're doing to find the new points, as well as actually finding the new points. So here, the 2 is on the outside, so I know it's affecting the outputs or the y values, which means it's stretching or compressing along the y-axis. So I know that this is going to affect the y values, so it's going to be vertical. To figure out whether it's a stretch or a shrink, it actually does help figure out what operation we're going to do. Here, the 2 is multiplied on the outside. So when something's on the outside, I'm just going to do the operation I see. So I'm going to multiply y values by 2. That's going to make the y values bigger, which means this is going to end up being a vertical stretch. So this one is going to be a vertical stretch. We're going to multiply the y values by 2, which is going to make the y values bigger. Okay, so let's actually find our new points. So I'm going to multiply only the y values by 2. All right, so here's our first point. The original was -2, 4. My new point will be -2, 8. I multiplied the y value by 2. The next point would be 0, 6. The original was 0, 3. The new one is 0, 6. I multiplied the y value by 2. The next one was 1, 0. This one is actually going to still be 1, 0 because 0 times 2 is still 0. And then the last one is going to become 3, -2. I multiplied the y value by 2. -1 times 2 gives us -2. So there's my new point. So let's, of course, graph those so we can see how that looks on our graph. So the point -2, 8, my graph right here only goes up to 6. So -2, 8 is going to be a little bit off my graph. I'm just going to kind of put it approximately where it might go. But I know it would be like a little bit off my graph up here. Okay, my next point would be at 0, 6, which is right here. My point at 1, 0, this one actually stayed in the same spot. And then the last point is at 3, -2. So when I connect those, here's my new graph for A. As we can see, so the one in black is our original, the one in red is our new one. It's the same width as it was before, but we stretched it vertically, so now it's taller. All the y values are double, so it's 2 times as tall as before. Okay, so this one, a vertical stretch, multiplying by 2 made it 2 times as tall. All right, let's now look at B. I'm going to do B in a different color here. This one we have f of 2x. It's still, the function is still multiplied by 2, but this time the 2 is on the inside or affecting the x values. So I know it's stretching or compressing along the x-axis. That means it's going to be horizontal. But I do have to figure out whether it's a stretch or a shrink. That's, again, kind of the tricky part. Here, the C value is 2, which is greater than 1. So if you want, you can memorize all these cases here. I would rather just think about it rather than having to memorize all of that. Okay, so I already know it's horizontal. Now let's think of what operation we're going to do. Remember, when something is with the x, we actually do the opposite operation. This is x multiplied by 2. So the operation I'm going to do is I'm going to divide the x values by 2. divide x values by 2. So what's going to happen if I divide the x values by 2 is the x values are going to get smaller, which means this is going to be a horizontal compression. So that's how I like to think about it, is whether the x or the y values are going to get bigger or smaller. Here, the x values are going to get smaller, so it's a horizontal compression. All right, so let's, of course, actually find our points. Let me get rid of my multiplication from earlier. This time we are dividing the x values by 2. So I'm dividing all the x values by 2. So my first point, the original was -2, 4. If I divide the x value by 2, -2 divided by 2 would give us -1, 4. Okay. The second point, 0 divided by 2 is still 0. 0 divided by anything is still 0. So that point stays 0, 3. The third point was 1 divided by 2. It doesn't divide evenly. So in a case like this, you could either leave it as a fraction or put it as a decimal. So that would be 1/2, 0. Just a reminder, you can always, if you are not sure with your arithmetic, like adding, subtracting, multiplying, and dividing, you can always use a calculator like Desmos to help you out. So 1 divided by 2, it either gives us a decimal of 0.5, or if you click this, it changes it back and forth between decimal and fraction. So you could use either. And then the last one is 3 divided by 2. Again, doesn't divide evenly. So you could leave it as a fraction, 3/2, 3/2, -1, or use Desmos, or some kind of calculator so that you don't have an error. So 3/2 is 1.5. So you could leave it either way, decimal or fraction. Okay, so let's plot these points and see how that affects the graph. So I have a point at -1, 4 is right here. 0, 3, that one's in the same spot as the original. 1/2, 0. This point means I would go to the right 1/2 and up 0. So it would be right here. And then 3/2, remember that's 1.5, -1. So I would go to the right 1.5 and down -1 right here. Okay, so when I draw that one in, here's my graph right here for B. As we can see, it's the same height as it was before, but this time it's half as wide. It's skinnier because we compressed it horizontally. So this one is half as wide as before. So we've got 2 more that we're going to look at. So both of these were multiplied by 2, which is a C value that's greater than 1. If we look at our next 2, C and D, we're going to draw these on the second graph. That way we just didn't have too many graphs on the same coordinate plane, because that'd make it a little hard to see. If you look at C and D, these are both multiplied by 1/2. So in this case, this is what we mean by C is a number between 0 and 1. It's a decimal or a fraction that's less than 1, like 1/2. So let's look at these two. So 1/2 times f of x. This is multiplied. So I know it's on the outside. In this case, the half is on the outside, so it's affecting the y-axis. I know it's going to be vertical because it's affecting the y-axis. I got to figure out whether it's a vertical stretch or compression. To help me do that, I want to think about what operation I need to do. Remember, when something's on the outside, we're just going to do the operation that we see, which in this case is multiply y by a half. Multiply y by a half. If we multiply y by a half, that's actually going to make the y values smaller. So this one is going to end up being a vertical compression. Vertical compression. And we're going to multiply y by a half. Okay, so to actually find the points, I'm going to rewrite my points here. You still have them at the top of your page, but I'm going to rewrite my original points here. So we have -2, 4, 0, 3, 1, 0, and 3, -1. Those were just our original. This time I am multiplying all the y values by a half. Multiply the y values by a half. Should have done that all in the same color, but. Okay, now, if you're not the greatest at multiplying or dividing fractions, don't forget you can use a calculator to do the multiplying and dividing for you. I'd rather you take the 4 extra seconds to type it on a calculator or Desmos than get the wrong answer. So the first point was -2, 4. If I multiply the y value by a half, I have -2, 2. 4 times a half is 2. Again, if you're not sure, use Desmos. 4 times 1/2. To do a fraction, you just do 1 divided by 2. 4 times a half is 2. The next one is 0, 3. I multiply the y value by a half. That would be 0. 3 times a half is 3/2 or 1.5. You can leave it either way. And again, feel free to use a calculator if you're not sure. 3 times 1/2 is 1.5 or 3/2, depending on how you write it. Both are the same. The next point is 1, 0, because 0 times a half is still 0. And the last point is 3, -1/2, because -1 times a half is just -1/2. All right, so if we look at all our y values, all the y values got smaller. So this is a vertical compression. So let's plot this. We have -2, 2, 0, 3/2. 3/2 is 1.5. So I go 0 over and up 3.5. So up 1.5, or sorry, up 3/2, which is 1.5 right here. The next one is 1, 0. So this point actually stayed in the same spot. And then the last point is 3, -1/2. So I go over 3 and then down a half right here. So when I draw that in, that's my graph for C. As we can see from that one, it's the same width as before, but we vertically compressed it, which means it's shorter than before. The y values are smaller, so it's shorter, or in other words, it's half as tall as it was before. So vertical compression affects the y values or height. All right, last one. D is f of 1/2 x. This time we're still multiplying by a half, but the half is on the inside, so it's affecting the x values. So I know it's going to affect the graph horizontally. So it's going to be horizontal, but I got to figure out whether it's a stretch or compression. To help me figure that out, I'm going to decide what operation I'm going to do. Anything with the x, we do the opposite operation. So right here, it's a 1/2 times x. The opposite is to divide. So instead of multiply by a half, we're going to divide the x values by a half. Okay. Now, dividing by a fraction or a decimal is actually going to make our x values bigger. And we'll see when we actually do the operations why that works. So dividing x by a half is going to make my x values bigger. So this is going to be a horizontal stretch. So this one, f of 1/2 x, is a horizontal stretch. To do the operation, we're going to divide the x values by a half. So coming back up to our original points in blue, this time I'm going to divide all the x values by a half. Okay, if you're not sure, and I know a lot of people don't prefer to deal with fractions, if you're not sure, use a calculator. -2 divided by a half, if I'm dividing something into fractions or smaller pieces, I'm going to end up with more pieces. So -2 divided by a half. Let me clear those from before. So the way I would write that, -2 divided by, it's going to make a fraction, but then I'm just going to do 1 divided by 2. So -2 divided by a half is -4. So the first point becomes -4, 4. The next point, 0 divided by a half is still just 0. So that point stays 0, 3. This next point, 1 divided by a half. If you're not sure, use a calculator. 1 divided by 1/2 is 2. And the last one is 3 divided by a half is 6. Okay, so let's go back to those points. So use a calculator if you're not sure to get the correct point. This divided by a half, 1 divided by a half was 2. So that third point was 2, 0. And then the last point, 3 divided by a half was 6. So this point is 6, -1. So let's plot those. So we have -4, 4, 0, 3. This point stays in the same spot as the original. 2, 0 is right here. And then 6, -1 is right here. Okay, so if I connect those like this, that's my graph for D. So compared to the original, the height didn't change. It's the same height as before, but the width changed. This one is 2 times wider than before. 2 times wider. Okay, so that's how compressions and stretches affect our graph. If it's affecting the x values, it either makes the graph wider or narrower. And if it affects the vertical y values, it either makes the graph taller or shorter.